Hello everyone and welcome back to another video here on the Hidden Quantum Champion series. Today we are looking again at a hidden champion from China, which is called ArcLight Quantum. They are building a platform to program quantum computers, and if you are interested in that and you want to learn more about it, then stay tuned for today's video. Get yourself something to drink so we stay hydrated, and let's jump right into it. So here we are on the website. It says ArcLight or ArcLight Quantum. I have already turned on the translator of my browser so that we have everything in English, because originally the website is in Chinese and I think there's no English version of it available. So if something sounds a bit odd, it's probably the translator of the browser. I guess on the website in Chinese it all makes sense, but my Chinese is not good enough, so I cannot really, let's say, understand anything from that unless I turn on the translator. Okay, so here we have first of all this carousel which says different things. So Arc Quantum Cloud Platform, we will talk about the cloud platform in a second. Then we see here Zonke, ArcLight, Light Up the Future, and then also as a third one ISQ, the first quantum programming and verification platform in China, and we will learn about that more in today's video. So we are from the Chinese Academy of Sciences. So basically the premier league of Chinese science institutions is the Chinese Academy of Sciences. Back in my PhD days, I also got to visit China for some scientific conference, including, for example, the CIMIT in Shanghai. And of course, there were also a lot of people from the Chinese Academy of Sciences coming there and talking with us about different quantum topics. So quantum scientists in the Software Institute, we are committed to promoting the practicalization, engineering and commercialization of quantum computing. We are determined to shine our own light for the development of national quantum science and technology and the progress of human quantum science and technology. Learn about our information. So Zonke ArcLight is building quantum computing software and application systems together with various domestic hardware technology research institutions. And I think we have touched on a couple of those before in previous videos. So if you haven't seen them, go check out our Hidden Quantum Champions playlist. You can always see in the thumbnail of each video the logo of the company. And I mean, if you see some Chinese in there, it's a good indication that you're looking into one of the Chinese as well. Oftentimes it's also indicated in the title. Then, I mean, there's a new section here, so good news. Arc Quantum ranked third in the artificial intelligence field of the 8th International Frontier Science and Technology Competition. This is from 2025 February. I'm recording this video in May 2026, so this is, let's say, not the latest news. It's a little bit outdated. Product introduction. So here we now see the different, I guess, properties of the platform. So quantum EDA, quantum automation design for autonomous software, forming a set of quantum chip design tools with a high degree of automation in the description, testing and verification of quantum chips and quantum circuits. It mainly includes technologies quantum hardware description language, quantum circuit optimization and equivalent verification, quantum model detection technology, design optimization and detection of quantum chips. It aims to provide quantum chip design services for practitioners in the field of quantum computing and quantum devices. So this is, let's say, targeting very much the low level. This is targeting the production stage, the testing stage of this quantum technology. Then we have the quantum program development platform. So as the first high-level quantum programming platform in China, it is a tool chain that can meet various needs, connect a variety of different quantum computing hardware, and integrate quantum programming, compilation, analysis, verification, debugging, and other functions. Realize the compilation, analysis, and debugging of general quantum computing programs and the convenient development of a variety of quantum algorithms. Then we have quantum machine learning platform. So the overall framework of the quantum machine learning platform algorithm mainly follows the existing machine learning framework and its function is to replace the more complex part of machine learning with the quantum version for calculation, so as to improve the overall computing efficiency. So that is, let's say, already on the algorithm stage now, right? So we are going from, let's say, getting the chip up and running, fine-tuning and running some, let's say, low-level commands all the way towards the development stage, all the way up to the machine learning algorithm stage. So getting people easy access to quantum machine learning. Then we have the quantum measurement and control system, so a software and hardware interaction platform with functions such as data acquisition, data processing, parameter scanning, and hardware debugging based on the existing quantum hardware environment. I guess that goes into the same or into a similar layer like the quantum EDA we talked about before. Then we have the application of quantum computing, so through combination of quantum-inspired computer algorithms, small-scale quantum computing and classical computing and hybrid quantum computing, it can provide industry applications for various industries. And then we have here, so after the application layer now on top, we have other cutting-edge scientific and technology research, so cutting-edge science and technology research, big data platform, data detection platform, blockchain platform, intelligent optimization and simulation platform can provide cutting-edge artificial intelligence, big data, security detection, blockchain simulation, image recognition, and intelligent optimization and other algorithms. So this is now not only into facilitating applications, but really like going into the application layer itself as well. So basically, let's say the whole software stack that is sitting within the application of quantum computing. Then finally down here, some relevant links like the company introduction and so on, the solutions and the company address, which is based in the Ginza, Quantum Ginza. I guess like in the Japanese, I think in Tokyo there's a quarter called Ginza, but here the company is based in Beijing in China. Good. So let's quickly check out the product center. I guess, okay, we've seen the product center. Let's see what we have in terms of solutions then. So quantum computing redefines financial model, financial technology solutions. So we are looking into the finance part first. So many calculations can be performed more efficient on quantum computers than on existing classical computer or even supercomputer. This is a potential game changer, especially in the banking industry and other fields. Quantum algorithms can be applied to risk value calculation and portfolio fluctuation optimization. Quick note from my side, we've also seen portfolio optimization, time series forecasting, for example, for stock value forecasting. So I guess there are many different mathematical functions that are interesting to be mapped on quantum systems, quantum computers here. We also know that some of the financial forecasting is done with Brownian motion simulation. So there are some cases where physics is being applied to stock markets. And I mean, in that case, we see here that there are some applications that they're focusing on. Then back to the text, right? So on the other hand, quantum computing may expose banks to security risks. So some banks are deploying quantum key distribution or post-quantum encryption to resist the risk that quantum computing may crack the current encryption system, because this is a common problem faced by society. And also, again, a note on this, there are companies already selling these quantum key distribution systems, these quantum encryption systems. They are available now on the market. We have seen companies basically from all over the world that are offering this. If you're interested in this, check out the Hidden Quantum Champions playlist. There are also videos about those companies in there. Back to the text, the applications of quantum computing and the way quantum computing also affects finance. Before full-size quantum computers are available, quantum computing applications and quantum computing may have an impact on the financial industry in the short term. There are several ways, the most prominent of which is the combination of small-scale quantum computing and classical computing in the so-called hybrid quantum computing. The other is the potential implementation of quantum-inspired computing algorithms on classical computer hardware. Quantum-inspired computing is based on the idea that a problem that is difficult to solve on a classical computer may become easier to solve, which is redefined as a way inspired by quantum physics. But execution is still classic. Many applications related to artificial intelligence are also applicable to financial services, including trading strategies, treasury bonds, and asset management, option pricing, new financial models, portfolio optimization, risk and uncertainty forecasting, and customer real-time behavior positioning. If financial services companies are currently too risk-averse and unwilling to expand their customer base due to the limitations of computing power, quantum computing can expose the industry to 2 billion people without bank accounts, reducing the annual loss of 40 billion US dollars caused by fraud, poor data analysis, and reduce false alarms by 80%. The conclusion is that the biggest benefit in the near-term future of quantum computing will appear in the field of financial services, which explains why industry giants such as JP Chase, BBVA, and Goldman Sachs are actively exploring quantum computing. How to distinguish between classical computing and quantum computing? It is a solution. If a solution uses the quantum mechanics principle of superposition and entanglement, it can be called a quantum solution, or at least a hybrid classical quantum solution. If the solution does not take advantage of these phenomena, we will call it a classical solution, even if it may look like an ordinary classic computing solution. Quantum-inspired computing can be realized by using standard computer hardware or dedicated computer hardware. The origin is the classic. Usually, quantum heuristic software is also quantum ready. Once the hardware is available, it can be easily ported to a real quantum computer to run. When running on a real quantum computer, the software will be more powerful. And that's basically everything that is mentioned here about the financial applications. I guess most of it speaks for itself, right? So yes, we have seen the first banks that have been moving. I think HSBC is also one of the early movers here that's not mentioned in this context here. But yeah, there is a lot of movement happening in there and a lot of exploration currently for these quantum. Other categories that are being targeted here are medical and health, new energy, new materials, and other. Let's quickly check out the new materials as well, because I think that could be an interesting one for quantum computers as well, where we might see some interesting progress in the next time periods. So solutions for new materials. Quantum computing makes new materials more likely. And I guess new materials is a very broad thing, right? So it's not only materials as in, I don't know, new materials to manufacture something and properties of something, but also new molecules that could be interesting for the pharma industry, and for that also health-related topics, or the chemical industry as in new kind of goods for processing something, right? So all kinds of materials are everywhere in life. The development of human society from the Stone Age, Bronze Age, Iron Age to modern polymer materials, semiconductor materials, the information age is closely related to materials. In order to not lag behind the node of development in the next era, we must strengthen the research and development of material science. Material science mainly studies the properties of various materials and their applications. The research process involves the preparation of materials, the processing of materials, the characterization of materials, and so on. At present, many high-end fields such as military equipment urgently needed new high-performance materials. The material industry provides a material foundation for national economic construction, social progress, and national defense security. However, the research and development cycle of materials is long, and there are many disciplines which is difficult to develop. Traditionally, the research and development of a material requires scientists to conduct thousands of trial and error experiments, which consumes a lot of manpower and material resource and will cause a lot of waste in the research and development process. At present, it is the era of information technology and the era of big data. The development of computers is promoting great changes in material research and development. Maybe a quick step out of the text again. So indeed, there's a lot of development here. And I mean, if you want to look out for it, you can look for things like spintronics, for example, the idea of creating a material type of system where instead of using electric currents, we use magnetic properties to process information, which is also a very promising field. There's of course the whole superconducting research part, right, where we are trying to build materials that can conduct electricity with less or zero resistance at elevated temperatures, elevated in the sense of non-super cryogenic temperatures, because that is not something that can be put on a landline, right? If you need cryogenic environment, it's hard to get this. But it's also interesting for things like medical research, right? Think about NMR scanners or superconducting magnets that are required for that. So there are various different areas where this material research kind of plays a role here. So back to the text. Before we do that, one step back. So manufacturing these materials in the lab is quite complicated, and it's also in a way slow because you have a huge parameter space. You can think about molecular beam epitaxy chambers, like specific ovens that you're using to grow certain crystalline materials. You're like putting in hyper purified materials, like, I don't know, you have a hyper purified carbon, silicon, maybe even by specific isotopes. We've talked about that in previous quantum computing company analysis before, right? So like purified not only as in purified to a specific class of atom, but then also to a specific isotope. So it's very, very challenging to even produce these materials, and then those go into these let's say manufacturing systems like an MBE, molecular beam epitaxy chamber, where you then kind of use molecular beams and combine them at certain pressures and certain heats to kind of crystallize on the wafer level so that you can then do research with those. And it's actually a quite broad parameter space. Think about, let's say you have 3 different materials. So you have the beam chambers, and the beams are being created by heating up those materials in the individual spots, right? So you have different heats that you can play around with. Then you have the wafer level, which has to be cooled so that they condense and form crystals. So there you also have a different temperature range. Then you can play around with all the fluxes, like you can reduce flux of one and increase the flux of the other. And then you can change the let's say, amounts of material that you are depositing so that you get different crystal combinations. And then you have different crystal phases. Think, for example, about pure carbon. So you might have your little pencil where it's more on a graphite or maybe even a graphene kind of setup. But you can also have diamonds, which is all just carbon, but basically in a different way. So it's set up in a different lattice. And now think about if you're taking multiple different atoms and you're combining them into a crystal lattice, you even have more different ways of ordering them. And now finding the right parameters to get the right crystal phase is already challenging. Then finding the right materials to combine with each other to get a certain property is even more challenging. And that creates, let's say, a lot of a high parameter space to try out things. And if you don't understand the underlying properties, or if you cannot simulate them because they're quantum and they don't run on classical computers, you're creating a lot, or you have to do a lot of trial and error to actually figure out the right combinations, the right settings of materials to reach something. And I mean, I've seen that also in my research career, that my colleagues that were actually manufacturing the materials, they had to try out a lot of different things. Also myself, and preparing samples in the clean room for this material growth step, we had to change a lot of different things to actually get to the level where we could grow, for example, these topological insulators in a way that it was even useful to do measurements with. So material research is very, very complicated. There's a huge parameter space. And if you can, for example, use algorithms, if you can use compute to increase the performance of this research, I think it kind of boosts your society quite a bit, because you will be able to manufacture new materials and build new businesses, build new applications on top of these, right? But okay, now back to the text. So I think we were at the national strategic level. The status of materials is particularly important. China has entered the middle and late stage of industrialization, and it is of great significance to support the implementation of China's strategy to strengthen China's manufacturing strategy. China's material research started late. The technical level is not high. The dependence of foreign technology is greater, and the research experience has not been accumulated much. However, the core technology of high-performance materials must be in our own hands, and we can't let foreign technology lead the way. I guess to take a step back from that, I mean, looking at the supply chains of these systems to do material research, I think they're still pretty global. So let's say thinking about molecular beam epitaxy chambers, it is something that only very few companies on Earth can build. I think there is likely going to be some way that countries are interacting, but of course I can also understand that there's a certain willingness to kind of take more ownership, take more of the value in this generation of value here. And I mean, we are seeing similar things also across other industry sectors in the world, right? Like the semiconductor industry and the US, where they are trying to own more of the supply chain, similar to Europe, where Europeans say, okay, we need to own a little bit more the supply chain in the future, because we see that there's some disentangling between, let's say, the economic zones on Earth, and therefore the supply chains are becoming more fragile, right? So I understand that this plays an important role also for China and the strategy here, right? So back to the text. At present, the development of artificial intelligence and other computing simulation technologies has brought new vitality to materials research. Only by grasping the wave of informationization and actively researching and developing in the field of materials can we be able to overtake in curves. However, traditional computer simulation materials have certain limitations. The material system is very complex, and it is very challenging to simulate the material model efficiently on traditional computers. Quantum computers can achieve tasks that traditional computers cannot complete, and at the same time, they can do accurate and fast simulation of molecular scale. When quantum computing is compiled on electron atoms, it will be very natural in simulations such as the discovery of new materials and the synthesis of biomedicine drugs. We believe that quantum computers have great potential in the field of material simulation. On the other hand, quantum computers can simulate the properties of materials from microscale, and on the other hand, quantum algorithms can accelerate the processing capacity of material experimental data. We have reason to believe that quantum computers can accelerate the research and development of materials. So taking a step back, both on, let's say, exploring these huge parameter spaces that I talked about before, right? So using kind of AI or machine learning approaches to find patterns in these huge parameter spaces, and then guiding the experimental researchers, the material scientists, to kind of combine the right or turn the knobs in the right way that they can manufacture the materials at the desired properties. But then also the other side, where we say, okay, let's look at quantum physics, at the quantum physics side of things, and simulate on a quantum computer what combinations of atoms, for example, we need to build a crystal that has a certain property. And these both kind of combined into the whole material science and research field. That is what is promising here, right? Okay, let's quickly take a look at the news, because we had checked that out before, but I'm not sure if there is. Okay, maybe there's nothing more recent on here. Okay. Then let's also quickly check out the product center. Oh, no, not the product center. Sorry. I mean the download center and the platform. I think it's anyways leading into the similar direction. So this ISQ is the quantum programming software that they've developed, right? So China's first, I guess, or maybe most relevant quantum computing or quantum programming software, which is this ISQ. We've talked about that before, right? So it's spanning across different layers of the quantum software stack. So we see here the compiler of is QuantumQ accepts is ISQ programs as input and produce low-level code written and so on and so forth. But there's also simulators and so on and so forth. Okay. So you can, I mean, if you're interested in that, check out this documentation. There's also this platform here. And I think you can already get access to that. And I mean, if you would like me to get access to that and to do a video on that, let me know down in the comments below. Then I will request this, of course, as per usual. But yeah, here you can see the platform. And for example, Quantum C-Tech is a company that we've looked at in a previous video. SpinQ we have also mentioned before. So there are, let's say, units or systems to run on available, or corporations available on this platform as well. If you're interested in that, as always, let me know down in the comments below. At the end, quick part about the company itself, right? Let's see. So company profile. We are a high-tech company focusing on quantum software. ArcQuantum is a pioneer in the quantum computing software industry. It is committed to accelerating the development of quantum information industry, bridging together quantum software talents at home and abroad, forming advanced professional technical forces and providing customers with cutting-edge, convenient and safe products and services. The company is committed to narrowing the distance between quantum computing and commercial customers. It has provided customers with cutting-edge quantum machine learning, quantum computing, biochemistry, and other software products and technical services in many fields such as finance, new materials, new energy, biopharmaceuticals, and so on. Let's see. I think there's something about the company qualification. I guess that talks about the certificates. Yeah, you can see them here, that the company has got for their research and their work. And then, as per usual, there's a way to reach out to them as well, with their address in Beijing. And I guess that's it for today's video already. So that's everything I wanted to show you about ArcLight Quantum. I hope you found this video interesting and you watched and if you watched all the way to here, please give the video a thumbs up. I'm looking forward to see you again in the next video about the next hidden quantum champion. Until then, stay hydrated and bye bye.